Are there questions?
Oh. I just want to make one comment and one question. So, I mean, so group theorists are looking more and more into this type of question, but I mean, they mostly look at the first question that you're asking. So if you fix a finitely generated group, whether it can actually interact with the embedded density in one of those. So, particular thing I wanted to mention, there is a very nice result of Denisovsky. Basically says that every non-elementary acylindrically hyperbolic group embeds densely in S infinity. I mean, it doesn't matter, it's a huge, very general class of groups. Okay, that includes, for example, all hyperbolic groups. And another thing is a question that several people have asked. So for out of Q, okay, so it's a very simple situation. Can you find a dense finitely generated group that is amenable?
Okay, so I mean, I have the Thomson group, and I don't know if it's amenable.
Yeah, this is one of the reasons to ask this question.
Yeah, so if I was going to ask questions like that, but so I think those are very interesting questions to ask. Whether you, so this I haven't thought about that. The question occurred to me. What might be easier would be to actually find structures which don't have such a thing. For example, if you take the ordered random graph, does every dense subgroup contain a free group onto generate?
Yeah, so anything.
I'd be happy to answer that question.
So, for example, okay, so what can you say, in the things that you're doing? Can you say anything about the group that you get?
Well, it's going to contain free groups because we build it by back and forth. The problem is all those constructions that give you dense subgroup, they do them by back and forth, and it's very easy to construct free groups by back and forth because you kill relations at each step. It's extremely hard, almost impossible I think impossible to not. So yeah, those are very good questions. It seems like there might be a hope of proving negative statements for other things than the LO. But
yeah, but it's already very interesting.
Yeah, I agree. I'd like to think about that.
More questions?
Maybe you already said this, but so for the circular order, the automorphism group is not finitely generated?
Yeah, it is. So I sort of gave an argument that it was it was topologically 3 generated. Actually, you can play with it and show that it's 2, but that requires really ad hoc construction.
Actually, can you give like a relative bound? If it's finitely generated, if it's topologically finitely generated, then it's topologically finitely generated by at most.
Yeah, so I don't think we know of any group with, say, no compact quotient that really needs more than, for which we know we need more than 2 generators.
Yeah, but this argument suggests that 4 should be really way enough.
Yeah, I think even this theorem, maybe you need only 1 here. I sort of conjecture that probably it works with 1.
Yeah.
So 3 should be the right number, but I don't know of any example for which I know it's not 2.
Okay.
And what if the structure is not categorical, just saturated?
Yeah, so if it's just saturated, a lot of this goes through. I would need to think what exactly doesn't, what doesn't. But yeah, so I don't know exactly, but sure, send me about this.
Are there more questions? If not, so let's send the speaker again.